Okay, for my first video today, I will be doing a Geiger counter demonstration. Here we have a GQ GMC 500 Plus. It's a dual tube Geiger counter. The first tube is for normal use, and that's the tube on the bottom. And the tube on the top is for very high levels of radiation. That would be for like a Chernobyl or a nuclear fallout. And okay, so it's been sitting on this pillow for a while, and it's at 15 CPM, 0.08 microsieverts per hour, 0.10 microsieverts per hour, 0.013 millirads per hour. So it changes at random a little bit, because after all, most radiation is essentially random, quantumly. Now, for the first test, I will test a smoke detector. Just a regular smoke detector. It's actually very old. It's probably like 20 or 30 years old, and with the lid off, but everything's still not taken apart. And I will put the Geiger counter on top of here and balance it on top of here. And we have to wait about a minute for the count to stabilize, because basically it has to count all of the pulses. It has to count the pulses over a period of time in order to get a reading. So we're at about 56 CPM. Okay. And now here is a Vaseline glass or uranium glass container. And I will first show you that it glows. It glows. It fluoresces under ultraviolet light. Okay, now you put the Geiger counter in here, and we don't want it to change the direction of the display. And when it gets to a preset level, it starts beeping. The preset level can be changed. You can change it in the settings. It takes a while for it to fully register the count, and so that's why it took about a minute. And so now we're at about 116 CPM or so. It goes up and down a little bit. Okay, I got interrupted. I accidentally pressed the volume key on my phone and stopped the video. Now, Now I will take this out of here and for a minute, let the count stabilize to background levels, or at least, yeah. And then we'll have the final test source, which is a couple thorium lantern mantles. Basically, they're thorium. They're mantles for lamps that use gas that contain thorium salts to make the flames glow very brightly. Okay, so now we'll put this Geiger counter on the bottom tube, right on the bag containing the thorium mantles. And that is about 1,000 to 1,100 CPM. And this, so let's just look at that. It's so about 1,050 CPM or so, and 6.9 microsieverts per hour, 0.68 millirads per hour. And we'll take that off and see how it goes back down. So that concludes the test of the Geiger counter with various radioactive samples. Okay, I need to make a minor correction to this video. Lowercase m, capital R is actually milliroentgens. And roentgens is a measure of the radiation that's going through the air, whereas rads is a measure of the radiation that is absorbed. And to convert between roentgen and rads, you need to multiply the roentgen by 0.88. Okay, that concludes the correction to this video.